Alright guys, welcome back. We are going to be looking at section 5.1 next. Section 5.1 is calculating areas between curves. So the problem that we're going to look at today is problem number 57 from your text. And the question asks you to find a value b such that the line y equals b divides the region bounded by y equals x squared and y equals 4 into two regions with equal area. So I want you guys to try this problem out for a second. If you get really frustrated, move on to just watching the video. This is a pretty challenging problem, but I would really start by making a picture of what's going on. So try it out and then tune back in. Okay, I'm going to assume that you did that, and we are going to go over the problem now. So, first step to solving this, you're not actually given a graph. The first step would be to draw a picture. So drawing the picture would include drawing the graph. So here I have the graph of y equals x squared and the graph of y equals 4. So what we're being asked to do is we're being asked to divide this region that would be between the green and purple curves in half using another horizontal slice. So I'm going to draw that horizontal slice in. I'm going to use a lot of colors today, so hopefully this one shows up. Let's see. Yeah, that's not so bad. Okay, so I'm going to draw in the line y equals b. Okay, so the idea is that we need to choose B so that this area here is equal to this area here. And I'm going to shade those in two different colors. So we're going to have a purple area right there. And we want the purple area to equal, let's make this a green area. Okay, so something that can make our problem a bit easier is recognizing some symmetry in our picture. So asking for the purple area and the green area to be equal, you don't need half of the picture. You don't need the left half, because it would be the same thing as asking for this green and purple area to be the same. So I can just consider the right half instead of the whole thing. So that's important. Another thing that you want to do is you want to label some important points. So any intersection point is pretty important. So this point here is where the graph y equals x squared intersects y equals 4. That happens at the point 2, 4, because 2 squared is 4, right? Basically, to figure this out, you're setting x squared equal to 4. So you're going to do a similar thing here to figure out what that point should be. You're going to have x squared equals b, so x equals the square root of b. So this point here is square root of b, b. Okay. Other things that we want to do, I think in terms of the picture, it's just about all that we need. Just formally stating our problem, we want the area of the purple to be equal to the area of the green. So that's step one, is coming up with a good picture. Step 2 is going to be calculating those areas. So we're going to start by calculating the area of the purple. So I'm only looking at half of the shape, and I noticed something. The shape kind of looks like this. You have the top half is green. The bottom half, which doesn't go quite as far, is orange. And then this side here is purple. So what that means is that you actually have two shapes. Because remember, when you're calculating the area using an integral, you need the top function minus the bottom function. So for part of this, the top function is the green and the bottom is the orange. And then for part, the top is green and the bottom is purple. So you have to be careful with this. So you end up actually having to compute two areas here. You're going to compute this striped purple, and then this dotted purple. So let's start with the striped purple. Area for the striped purple is going to be the integral, and it's between the orange and green. So we do the top minus the bottom, that's going to be 4 minus b. We're integrating with respect to x. So x here is going between 0 and square root of b comma b, because this right endpoint here is root b. This top endpoint here is 2, 4. Okay, so then we're going to go from 0 to the square root of b. We're going to integrate this with respect to x. This becomes 4 minus b x. You're going to evaluate that at the square root of b. Evaluate it at 0, and then subtract. Here you're plugging these values in for x, not for b. So the area of the striped purple is going to be 4 minus b times the square root of b minus 4 minus b times 0, which is 0. So this will simplify down to 4 root b minus b to the 3/2. Okay, cool. So now we're going to calculate the area of the dotted purple. So area of the dotted purple, well, the top function now is the green function, which is 4. And the bottom function now is the purple function, which is x squared. So I have the integral of 4 minus x squared. And now what I want to do is I want to think about my bounds. So before I went from 0 to root b, now I'm going to go from root b to 2. So this is going to be equal to 4x minus x cubed over 3. And evaluate this at 2, evaluate it at the square root of b, and then subtract. So I have 4 times 2, which is 8, minus 8 over 3, minus 4 root b minus root b cubed is b to the 3 halves over 3. Okay, so the area of the purple region, is equal to this plus this result. So it's equal to the area of the striped purple plus the area of the dotted purple. If I add those two things together, I should get for the area of the purple region, 16/3 minus 2/3 b to the 3 halves. So I'm not doing this all out, but what I did here is I added this line and this line to get to here. So I found the area of the purple. Now what I want to do is I want to find the area of the green, and then we're going to set those two things equal to each other. So let's continue. I'm going to write this result up here and erase all of this work, but the good news is that you can pause and reflect back on it later. So area of the purple is 16/3 minus 2/3 b to the 3 halves. Okay. So now, what I want to do is I want to find the area of the green. And the good news is that the green region doesn't need to be broken up into pieces the way the purple region did. Okay, so to find the area of the green region, I'm going to take the integral, and the top function for the green region is the orange function. So I'm going to have b minus the bottom function for this green region is y equals x squared. The boundaries on my integration are the x values that I'm integrating over, so I'm starting at 0 and I'm ending at the square root of b. So integrating this, I get bx minus x cubed over 3. And now I'm going to evaluate this at the square root of b. I'm going to evaluate at 0 and then subtract. Evaluating this at the square root of b, I get b times the square root of b, that's b to the 3 halves, minus square root of b cubed is b to the 3 halves over 3. Minus, if I plug 0 in here, I have a 0, a 0, it evaluates to 0. So I get 2/3 to the 3/2. So now I'm going to set the area of the purple region equal to the area of the green region and solve for B. So I'm setting this equal to this and solving for B. So try that out for a second. I'm going to erase this integral here and just put the result here so that we can see the flow of the problem. But remember, you can always rewind. That's the beauty of YouTube. Okay, so the area of the green one is 2/3 B to the 3/2. Grab my green pen. All right. So the third step for solving this problem is to set the two areas equal to each other. When I said third step, I meant fourth step. So I'm setting area purple equal to area green. So this gives me 16/3 minus 2/3 B to the 3/2 equals 2/3 B to the 3/2. You have a 3 in the bottom of every single fraction. Multiply the entire equation through by 3 to get rid of all of the fractions, because fractions are horrible and we should avoid them at all costs. Multiply by 3 everywhere. Multiply by 3 everywhere. That's going to eliminate all of these. Beautiful. Okay, add 2b to the 3/2 to both sides. So you're going to have 16 equals 4b to the 3/2. Divide both sides by 4. Now, to get rid of a power of 3/2, you raise it to the 2/3. Remember that when you raise a power to a power, you keep the base and multiply the exponents. So you're thinking about, what do I have to multiply 3/2 by to get a 1? You multiply by the reciprocal. So I'm going to raise both sides to the 2/3. That's going to cancel these powers on the B and give me my result. So my final result is that B equals 4 to the 2/3. Wrapping up what we did here, the first thing that we did is we drew a picture of the problem. Then we broke our area into two pieces, the purple and the green. We computed the area of the purple. We computed the area of the green. And we set the two areas equal to each other. When I was computing the area of the purple, I actually had to break that down even further into two separate regions because the green function and the orange function was not going all the way across the interval. The orange function only got up to a certain point, and then the purple function took over. So hopefully this was informative. And yeah, I'll see you guys all next week. Tune in to virtual office hours. They're Mondays, 3 to 6. Blackboard Collaborate. Keep going to class and stay healthy. Bye, guys.